Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to show you how I will do full assembly of my mini blender. If you look at this photo, this is a 3D rendered image of my mini blender. Actually, I've done the assembly in Solidworks. So in this video, I would like to show you how I did this assembly. Okay. The first thing, before you do assembly in SolidWorks, make sure that all the parts, small component is already done. Means that you have completed all your parts modeling. Then you can do assembly in SolidWorks. Okay, to do assembly, you click a new document here. So I will go for the second option, which is the assembly. Then I click OK. Okay, if you look here, and automatically SolidWorks will ask which component that I want to insert in the assembly. Let me cancel this first, and I cancel this interface. Okay, if you look the interface of this assembly, it's kind of like different from the part modeling. At the upper portion here, we have the assembly tab. And the assembly tab, we have submenu, insert component, and so on. Okay, in order for us, okay, one thing, make sure that unit that we use is MMJS. Okay, in order for us to insert the component, we have to plan first the way of the assembly of the component of our product. For example, this product is a mini blender. So how I did it, I make it into two categories of sub-assembly. The first one is the upper part of the sub-assembly. The second will be the sub-assembly of the bottom parts. Okay, the parts, the sub-assembly of the top part will be the base, will be the lid, and all the other components that are close to the lid are the base plate, coil spring, internal gear, the pulley, and also the handle, and including the middle plate. I will do the first sub-assembly. So the base of the first sub-assembly of the top part, the base will be the lid. Then the second part, I will do sub-assembly of the bottom part, which is the container, the shaft, the blades, the screw, and the bottom rubber ring. Okay, I go for the top part sub-assembly. So what I will do under assembly here, I will insert the base for my upper part will be the lid. So I will click at the lid. And now the lid is here on the screen, but I do not click anywhere on the screen. I simply click OK. It means that the lid will be put into the origin point, and also the lid will become the base. So the first component that you insert in the assembly, it will become the base. It means that the lid, if you look under the list here, it have bracket F. F means it is in fixed mode. So it means I cannot move the lid. Okay, then I go to the bottom view. So the next move, I will insert the other component in proper order. So I mean in proper order, so the next component will be the base plate. So what I will do, I will insert my base plate. I will insert my base plate, and I put it somewhere above here. Then I need to put this base plate into the right position. So to do that, I will do mate setting. If here under assembly here we have mate, I click at mate. So I will set the relation, the cylindrical surface of this base plate must match with this shaft. Then I click OK. Then another thing to do, if you look, this base plate have the key. This surface of this key must match with this surface of this slot. So I will do the next mix setting. I will select the face of this key will match with the face of the slot. So if you look, if I click OK, if you look SolidWorks, it will automatically set it. It is in coincidence. So it means in position. Okay, the other mate setting is that I need to select the bottom face of the base plate. Sometimes it's quite difficult. Then I simply click OK. Then I go for section view. I click OK like this. Then easy for me to select the bottom surface of the base plate. Then I click at mate. The bottom surface here will match this plane. And if I click OK, then I off my section view. Now my base plate is in position. Okay, the next to do is I have to insert the coil spring. Okay, I go to insert component, then I go for my flat coil spring. Hold on, my flat coil spring. I open it. Then I put my flat coil spring somewhere here. Okay, sometimes in SolidWorks, sometimes the setting of your SolidWorks and the height show here, your sketches is off. If my sketches is off, it's hard for me to do the mate setting for this coil spring. Since the coil spring is a spiral shape and coil spring does not have the properties of cylindrical surface, so it's hard for me to do mate setting for cylindrical surface concentric with the shaft. So what I will do, since the coil spring, when I build this coil spring by spiral, I have a base circle. Let me on that base circle by height show, and I on the sketch. And now I have a part of circle. This curve can be used for my mate setting. So what I will do, I will do mate setting. Then I will select this curve, and I will select this shaft. And now my coil spring and the shaft have the relation of concentric. Okay, I click OK. Okay, another thing to check is that if you look my coil spring, at the end of my scroll screen, it has the hook here. The orientation of the hook is correct. So it means the orientation of my, sometimes if I undo this thing, if I do again, if I select this circle and I select this shaft, sometimes the position, if I go for anti-alignment, the orientation is in this direction. This direction of the coil spring do not match with the slot, since the hook need to be fitted into the slot. So I will undo this again. Okay, let me do again the setting. So this circle must match with this shaft, and I must use this orientation. I click OK, so the orientation is right. Then what I will do, I will do the other setting. It means here I have the flat spring, flat plane of the coil spring must match to this plane of this bottom plate. Okay, I can rotate the coil spring to make that the coil spring in position. So if you look here, I can rotate it to adjust. It means that the hook of the coil spring is fitted into the slot. All right. Let me click OK first. Okay. The next part will be after the coil spring, I will have a pulley. I will mount the pulley. So I will insert the pulley. Okay, I put the pulley somewhere here. Then I will do a mate setting. I go for mate setting. Then I will select the cylinder surface of this pulley match with this shaft. But if you look, the orientation of the pulley is upside down. So in here, we have made alignment. By default is anti-align. Then I go for align. So the pulley turns to the right direction. Then I click OK first. And now my pulley is in the right direction. If you look at the bottom surface of this pulley, we have a pin. The pin must match with this cylindrical surface of the end of this coil spring. So what I will do, I select this pin will match this surface. Then I click OK. Okay, I can drag the pulley. The pulley have the same relation here. Then it means that the pin is concentric with this. My next setting will be, I will select the bottom face of this pulley must touch the surface of the base plate. And now my pulley is in position. Then I click OK. But I need to check again the other end of my coil spring. I need to adjust it. Okay, to adjust the other end of my coil spring, I need to go to section view. I go to top view. Let me drag a little bit until I get, let me zoom it until I get this section. Alright, it looks like, okay, the coil spring and the pin of the pulley is concentric, but this end need to be adjusted again. So it means this hook, I need to adjust it a little bit so that the end of this coil spring hook will fit into the slot. Let me make some few adjustment here. Alright, and now the coil spring is in position. I off my my section view. Let me save the file. Full assembly. Alright. The next thing is I need to insert, after I have inserted the pulley, what I need to do, if you look here, I have inner thread. The shaft of the pulley, we have an inner thread. My mistake, not the shaft of the pulley. If you look, this is the shaft of the lead. The shaft of the lead have inner thread. So I need, because the idea we have inner thread, I need to fasten this thing with a screw, because the screw will lock the position of this pulley. So I need to insert screw M3.5. So this is the screw M3.5. So what I will do make the top of this surface of this screw head must match this surface. And if you look, the orientation of the screw is the other direction. Then I go for under mid alignment, I go for anti-align, so the screw go to the right direction. Then I click OK first. Then my other mate setting, okay, the screw actually I can drag it up. It maintains the same coincidence, the plane. And the next setting will be the cylindrical surface of the screw must match with this cylindrical surface. So now the screw, if I click OK, the screw is in position. Okay, another thing to check, if I go to section view, I go for front section view. If I click OK, if I zoom in, the thread of the screw kind of like not match with the inner thread. So I can rotate the screw until I get the thread kind of like, let me adjust it a little bit. I can rotate the screw until the thread kind of like mesh with the inner thread. Now the thread does mesh. Okay, then I off, then I section view again. If I click OK, now the inner thread of the screw mesh with the external thread of the screw mesh the internal thread of the shaft. Okay, let me off and let me save again. Okay, now the screw is in position. The next component, I have a gear. Let me off this hide this sketch so that I have a clean view. Okay, the next thing to do is I need to insert the gear latch. So I click at insert components. So I go for gear latch, then I click OK. Then I put my gear latch somewhere here, and now I can clone the gear latch by hold on my control key and drag the gear latch to this position. So I have two of them. Now I will do another mate setting. This cylindrical surface of this gear latch must match with this pin. Okay, one thing to make sure the orientation of my gear latch is right orientation, so I don't have to go for anti-align. I click OK. I can drag my gear latch a little bit upward, and now the bottom surface of this gear latch must touch this surface. So now my gear latch is in position. I can rotate the gear latch like this. Okay, okay, the next one will be the cylindrical surface of this gear latch must match this pin. And I click OK, and I drag this thing a little bit upward, and I select along the bottom surface of this gear latch will touch this surface. So both of my gear latch is in position. I can rotate like this, but something that, okay, let me click OK first. But if I try to rotate the gear latch, it's kind of like, because later I will insert the internal gear. I want to make sure that gear latch really fit into the internal gear teeth and they have no intersection. It's kind of hard for me to rotate since the pulley is rotated. So I can set, if I select the pulley, I right click at it, I make it fixed for a while, it means the pulley cannot be rotated. So easy for me to adjust my gear latch. Okay, my next move will be I will insert the internal gear. Let me go, where is my internal gear? Internal gear. Internal gear, hold on. Yeah, internal gear, then I click OK. Then I put my internal gear here. Then I will do mate setting. The cylindrical surface of this internal gear must match this cylindrical surface, but the orientation of this internal gear is to the other direction. So I go under this mate alignment, I go for line, so the internal gear will go for the right direction. But if you look, the internal gear is facing at this position. I can drag it a little bit up, but it will still maintain the concentric relation. And now the other setting is this surface of this internal gear must touch this surface of the pulley. Then I click OK, then I click OK. Okay, one thing to do is that I need to set the gear latch really mesh to the internal teeth of this internal gear. Then I go to section view, I go to top section view, I drag it down until I can see the section of this gear latch and the internal gear teeth. I click OK. Then I have this view. Then I can adjust the position of my gear latch. I can even rotate my internal gears. I got to adjust it kind of like the teeth is in the gear latch and the teeth, hold on, let me drag my internal gear kind of like in this position. And also this gear latch, I can rotate it like this. And okay, now my gear latch is in position. So the idea why they have this gear latch is that when we pull the handle, and the handle will rotate the pulley, and this gear latch will drive this internal gear, and this internal gear will drive the shaft with the blades. So the idea of having this gear latch is that once we pull, the shaft is rotated, the blades rotated, they have a free energy to rotate, they have a freedom to rotate. Since the gear latch, that's why they have this kind of gear latch instead of using external gear. Alright, that's for the gear latch. Okay, let me off the section view. Then after the gear latch, then I will do the handle. I go to normal view. Let me go for normal view. Okay, now I will insert the handle. Hold on, the handle. I put the handle here. Okay, the mate setting for this handle. Okay, if you look, this handle have flat plane here. Then I go for mate. Then I select the bottom surface of this handle must mesh with this flat surface. Then I click OK. Another relation is that if you look, this curvature surface and this curvature surface of the handle, they share the same concentric point. Then I will select this surface and this surface. Automatically Solidworks will detect it as concentric. Then I click OK. Now my handle is in position, but still the handle is not fully at right, since the handle have the freedom, if I drag the handle still have the freedom to rotate, so I must make the other mate setting. So the other mate setting is that if you look here, if you look in the list here for the handle, if you look at the handle right front plane is at the center of the handle. So it means my mate setting, I got to make the front plane of this handle must match with the front plane of the lead. So this is the front plane of the lead. So I must set the mate setting to coincidence. So what I will do here, let me close this list. Okay, what I'll do, my neck mate setting, okay, now I will select, okay, we have the list here on the screen. I click at this list, so I will select the front plane of the handle. The front plane of the handle must match. Then I close this list, then I select the front plane of the lead. Okay, the front plane of the lead. So automatically it will detect as coincident. Now my gear handle is in position. Let me save my file. Okay, for the upper part sub-assembly, I think the last component should be the the middle plate. Okay, the middle plate. So I need to insert the middle plate. The middle plate. Hold on. The middle plate. Where is my middle plate? Yeah, this is my middle plate. Then I click my middle plate. I put it at the bottom here. And okay, for this middle plate, I go for mate. Then I go for this cylindrical surface. Must match with this cylindrical surface here. And now we are in concentric relation. Okay, another thing to do, since the middle plate we have snap features here. The snap features, the plane of these snap features must match with the snap groove features at the lead. So if you look the lead here, so this surface of this snap features must match with this surface of the snap groove of the lead. Then I click OK. If you look the orientation now, as you can see, the snap, it does match with the, if you can look properly, it's really in line with the groove. All right, the next one will be this surface of the middle plate will be touching this surface. So it will be meshed into that surface. Then I click OK, will be coincident with that surface, and now my middle plate is in position. Then I click OK. Alright, I've done the sub-assembly of the upper parts. Let me save my file. Alright, my next move is I will do sub-assembly of the bottom parts. So I will go insert component. Then I will go for the container, the vertical shaft, the blades, the screw M1.5, and also the rubber ring. And I click open. This is the blades, this is the container, this is the rubber ring, this is the screw, and this is the vertical shaft. Alright, I need to focus first. Let me drag a little bit the blades closer here, and also the screw. Let me drag the screw a little bit closer. Okay, my first, okay, to do this assembly, the first thing, take note on this, I need to make this shaft, I right click at it, I make it fixed for a while. So if this shaft is fixed, so easy for me to do mate setting, since the shaft will not move. The only that move is the screw and also the blades. So I will do mate, and I will go for this top surface of the blade will match this bottom surface. I click OK, and I can drag like this. since the level is coincident, now the cylindrical surface must mesh with the spin. I click OK, and the cylindrical surface mesh with the spin. Then I click OK. Now my blade is in position. The next thing is the screw. The bottom surface of the screw must mesh with this surface, but the orientation of the screw is a wrong direction, so I go for anti-align, so it goes to this direction. I must click OK first, and this this cylindrical surface of the screw must match this pin, so the screw is in position. Then I click OK. Okay, this is very important. Please take note of this. Okay, now I have made the assembly of the blade and the screw, but if you look here, we have a repeated pattern. I have arm number 2, 3, 4, 5, and 6. So it means that I don't have to do this assembly of the blade and the screw again and again. What I need to do in assembly mode here, we have under linear component pattern. If I click at the arrow, down here we have curve driven component pattern. Okay, if you remember, if you look at my part modeling video of how I do the modeling of this shaft and how I do the repeated pattern of this arm, since we have 6 arms here and the 5 above is a repeated pattern of the base arm, it's kind of like similar approach. Okay, this assembly. So what I will do, okay, to do the curve driven component pattern, I need the curve for me to repeat this assembly of this blade and this screw. Since I'm using helix for my modeling of this arm, I need to on that helix, and the view here and the height show I on the curve, not the sketch, the curve, because helix is the curve. The sketch is 2D plane, the curve involves 3D plane. So this is the curve. So the curve is on. So I can use this curve as my guideline to be used as my curve driven component pattern. So it means I don't have to do the example of the blade and screw again and again. So what I will do, under the linear component pattern, I click the arrow, then I use curve driven component pattern. Okay, the direction will be the curve here as my guideline, the helix. And also the number of 6, because we have 6 of it, blade and the screw, we have 6 of them. So then under here I must use equal spacing. If I didn't check the equal spacing, I have to give the distance. If I check the equal spacing, it means since this is the spiral, so the blades and the screw will be equally distributed along this spline, along this helix. So I must check this equal spacing, and the number is 6. This one you must take note, this must be transform curve, and also must check on tangent to curve. Tangent to curve must be on. Transform curve and also tangent to curve. Okay, the face normal will be the face of this shaft, cylindrical surface of the shaft. Okay, since the helix is laying on that cylindrical surface, so that will be the face normal. All right, the components to pattern will be the blades and the screw. So as you can see, if I click OK, so we have the repeated pattern by another 5 of it. So this will save time. We don't have to do the assembly again and again. So let me save my file. Okay, now what I will do, since the shaft just now I have set it to fix, so I have to right click again to make it float so the shaft can be moved. Okay, now my assembly, I need to put the shaft in the right place. So what I will do, this shaft, I do make setting the cylindrical surface of this shaft must mesh with the, okay, I cannot use the cylindrical surface of this container. Remember, for this container modeling that I've done, I use kind of like twisting effect. If I use twisting effect, the properties of the cylindrical surface is gone. So I can use the reference of the bottom of the cylindrical surface, which is this cylindrical surface. Then, okay, before that, let me undo this first. Before I do the mate setting, let me cancel this thing. Since the container will be the base, I must click at the container, right click at it, I made it fixed. So the container will not be moved. So I do the mate setting again. The cylindrical surface of the shaft must match this cylindrical surface. Then it will go to concentric. I can drag the shaft upward like this. Then I can select the bottom surface of the shaft will be touching this bottom surface of this container, right? If I click OK, just to check, it looks like the okay, let me make this container float for a while. If I move the container to this position, then I make the container fixed. Let me zoom in just to check whether is there any interference of the component. Is okay, it looks like my blade is the right dimension. I need to check whether there will be interference. It means the blade is not touching any part of this inner surface of this container. So it looks like the blade is, the way I do the modeling of this blade is the exact size. So it means it's good. Okay, now I make the container okay, I already sent it to fix for the container. Okay, the next thing will be I made this rubbering must be concentric with this bottom part of the container. Then I drag the rubbering and this surface must touch the surface. So my rubbering is now in position, and the next thing to do, okay, since the container is fixed, okay, and the lid, let me check. If you look here, there are three components which in fixed mode. The pulley also in fixed mode. It means the pulley inside this is fixed mode. I got to set the pulley to float. And also the lid is fixed. I need to set it to float. So it means since only the component that is fixed is only the container, so I can mate this lid to this container. Alright. The next thing is that I will do mate. I will go for this cylindrical surface here, will mesh with this shaft, cylindrical surface of the shaft. So it has concentric relation. Then I click OK. Then this surface will touch this surface. Then I click OK. Then I click OK. Let me off the curve view height. I off the curve, so I have clean view. Let me go to standard isometric view. Okay, the next thing to check, if I go to section view, let me drag this section view up until this position, then I click OK. If you look, actually this shaft is not cylindrical shaft, is a square rod, and this square rod, and at the shaft here, at the bottom shaft here is a square holes. It kind of like the plane, this surface does not match with this plane surface of this square hole. So I need to do another mate setting. I go to mate, then I will select this plane surface of this square shaft to match this inside surface of the square holes. Then I click OK. Then I click OK. Then let me on off the section view again. Then now the shaft in right position. Right. And okay, I off the section view. Okay, I think the last thing to check is that if I go for the wireframe view, if you look here, the key of the container does not really in exact position into the slot of the mid container. Okay, in this case, if I want to rotate the container, since the container in fixed mode, so what I will do, let me go for display style, shaded view. The container have to be float, but the middle plate, I want to maintain my middle plate not to be rotated. So I must make sure that the mid plate, I set it to fix for a while. So then I will go to wireframe mode. Then I can manually rotate the container until it mesh, until the key in about right position. Okay, now I think everything is good. Let me go for display style, shaded mode. Then I go to standard isometric and let me make the final check. Okay, before that, I need to make the middle plate float and this container fixed. Okay, let me go for section view and let me check, and okay, everything is in good position. All right, Alhamdulillah, I've completed my full assembly of this blender. I hope by looking at this video will help you to do your assembly of your media blender. Okay, but before that, do not forget to click like and subscribe my channel. Selamat maju jaya. Assalamualaikum warahmatullahi wabarakatuh.